And we are live, guys. So welcome everyone. Welcome everyone to the first The Sound of AI Conversations session. So first of all, just a couple of words regarding like this new series that you have here on The Sound of AI. So I'm going to have informal chats with researchers, engineers, and business leaders in music and the audio tech space. The idea is basically to have like 1 or 2 conversations per month with these like type of people, and the session ideally will last 1 hour or so. The idea for this session is to be interactive, so that you guys like can interact with me, but most importantly interact also with the guest, right? So if you want to like ask questions, please write all of your questions in the chat, and so you can directly like interact like with the guest. And talking about the guest, so today's guest is Tristan Behrens, or Dr. Tristan Behrens, I should say. So Tristan is probably many of you may already know him. So he's an AI expert, and he's been like teaching deep learning, machine learning. He's been also like advising other like startups like in the space, and most importantly, probably for the Sound of AI community, he's like a great force in AI music, and he's been like very, very active in the space. So Tristan, thank you very much like for being here. It's great to have you here like as the first guest like for this new session.
Valerio, I feel honored. It's great to be with you today. Thanks for the kind introduction. Thanks for inviting me.
That's great. Cool. Okay, so I'd say let's get started with basically like something like quite obvious. So Tristan, what's your background and how did you get involved into AI music?
Oh, this is a great question. How much time do we have, Valerio?
Okay, yeah, no. Yeah, we
Okay.
have a lot of things to cover.
Yeah, a long story short. So the short story is that I'm a musician, an artist trapped inside the body of a computer scientist. So when I grew up and I was a teenager, I started programming, and I seem to remember that the first programs I wrote were something like composing a little music, so getting some beeps out of a computer in the 90s. And then I had this feeling that I should look closely at computer games, like implementing computer games. I was always so inspired by those games that were available. And then someone told me to go into computer science, do a diploma, and then ended up doing a PhD. And there was this great coincidence that when I studied computer science, I also started music production. So composing music with the computer in 2003, I think. And I discovered that the computer is just one of the most powerful tools that we have when it comes to human creativity, because it can do so many things and in just one machine. Back then, the machines were bigger, and now they're small. And well, after my studying in artificial intelligence and my PhD, I went into industry, did a little bit more like serious software engineering stuff. But then I discovered deep neural networks, and I also discovered their capability of like generating art, generating text, generating music. And since 2018, I'm just almost 100% in that field, like doing sounds and doing music and images. Is so much fun, I tell you.
That's really cool. So I think like this is a story like that is similar to many of us who are interested like in the space, I would say. And but I know that like last year you started doing some interesting experimentation with classical music and generation of classical music,
Yeah, yeah,
specific
yeah,
music in the style of Joanne Sebastian Bach
yeah, yeah,
chorales, right?
yeah, yeah.
So yeah, what were like those experiments about?
Yes, also very amazing. I seem to remember, I mean, deep learning, there's so many things that you can do, so many neural network architectures, and amongst them is the LSTM, so for sequence processing. And one of the first use cases was actually yeah, music generation. So Schmidhuber and Hochreiter did some experiments with that, I think with jazz music. And now, I mean, not so many years have passed, but now this Johann Sebastian Bach like chorale data set with 350 chorales is something like the hello world for everyone who would like to do music generation. So for you out there, if you want to get started, there's a way to go. The data set is freely available. Plug it into your network, can be an LSTM or a transformer, and then you have this up and running. And this is what I saw, that I got this up and running in not so many weeks. So it was I had to learn the business, how to do that, how to do the data pre-processing. And then after first, like even interactive prototypes, I was very happy. And then I could say I was unstoppable. I continued and slowly but surely went into also other domains like heavy metal and other architectures. But what convinced me the most is that after not so much of training, the neural network already generates some interesting results. So it's most of the time harmonically sound. So the music that comes out of this corresponds to the rules behind that kind of music without actually me implementing the rules. And that's what I like. I mean, I'm a computer scientist, and well, computer scientists tend to be very lazy. So they optimize and automate things. And if you have a neural network and you just throw in the data and it learns all the rules of music composition for Johann Sebastian Bach, then everyone is happy. And that's what I did.
Yeah, I think like that's really cool. But I mean, as a musician, however, on the other hand, I think like it is really interesting to have your input into the generation process, right? So
Yes,
you
yes.
said like if you have an RNN or if you have a transformer model, perhaps,
Yes.
basically you have a machine learning model that learns a lot by itself and it abstracts these rules. But in the end, I think like it's really cool if you are also like someone who's really close to the music as a music theorist or as a composer to actually try to abstract like some of those rules yourself and pass them like to the machine. And indeed, I do believe like that the best option for generation is when you have a sort of like synergy between machine learning as well as like some rule-based model.
Right. So my personal opinion is that I actually don't focus on AI for music that works on its own. So I don't want to push a button and then go out of the room, come back, and there's a perfect song just generated by AI. My focus is actually the human-machine interaction, that I have a model which is trained on some sort of music, and I interact with the model in some sort of dialogue, like really back and forth, crystallizing ideas into songs that I'm later gonna release. And I think this is very powerful. So having something like a neural network as an example that can generate with the click of a button tiny little ideas, and then taking those tiny little ideas and merging them into something bigger that tells a story. I mean, that's the thing that I like the most, this level of human creativity where you interact all the time with a deep neural network to get the best out of the whole idea.
Yeah, I think like that's really really powerful. A question that I have is, what did you learn during this initial experiments in classical music with Johann Sebastian Bach?
Well, I learned a lot about when you look at the music, you learn a lot about basic triads and chord progressions. I mean, that's what this music is about. It's just chord progression, one chord after the other in a very strong structure. What I also learned is that like doing this kind of experiment does not require a big neural network. It's just one or two layers of LSTM, which is very tiny. And you can even train it on your computer, so you don't need a supercomputer to do that. So it's actually a low-hanging fruit. That's why I call it Hello World. Because, well, if you have the right sources, it's not gonna take you that much time. What I also saw is that you can kind of visualize what the neural network is thinking, and you see that it's sometimes contemplating which are the possible next nodes. And you can see that in the activation, so that you have one node followed a couple of other nodes, and the next one can be like 1, 2, or 3 different nodes. And then just like randomness decides which of those paths to take. And it's like a tree that it moves through. Although, as we cool people say, those deep neural networks are continuous. They're all working with floating points. You see those roots in the activations when something is lighting up the next node. And I find this very, very amusing because you can kind of look at what it's thinking about.
Right. Yeah, I think like that's that's quite something. And I also had like that impression that by, I don't know, like experimenting with music and generation of music, I would also like learn not just like technical stuff, like computational stuff, but also like
Yeah.
get like ideas like and get like deeper into the music itself. So this
Yes.
is like something weird, right? Because like you would say, yeah,
Yes.
you are like a computer scientist, like you are like an
Yes.
AI person. But like when you work like on such interesting type of music, then it's you just like get into it and you learn by
Yes, you do.
experimenting like with the technology as well.
Yeah.
And
Yeah.
this is a great feeling.
It's amazing to see what kind of variability there is and what kind of patterns unfold. There's in my work, there's sometimes this use case where I have, for example, a drum beat, like 4 bars of drums, and I also have like a bass. A bass is playing a tiny little melody, and then I ask the AI, like, give me a guitar that fits that. And you see things that actually do fit, and it never shows you things that do not. That they show you only things that fit, and you also see that there's so many possibilities that you could put on top of those two instruments. And this is also like, it inspires a lot. You see, in music composition, it tells you that there is like a branch of nonlinear paths that you can follow in order to do that. And the deep neural networks just show you with a click of a button what is possible, what are the next steps you can take. And I have to admit, it's a lot of ideas. Sometimes it's too many ideas. So I'm a creative person. Don't get me wrong. So I know what it means to have a writer's block, for example, like sitting on a balcony, not having any idea at all. And while I was developing tools and testing this neural network, it gave me one idea after the other. So I was thinking, okay, let's implement copy paste. Let's test copy paste. And then, ooh, Jesus, this idea is good. I should stop and put this idea into my DAW and turn it into a full song. And I have to stop myself. So my hard drive is still full with MIDI files that I actually did not work with, composed by AI and me, and there's still so many ideas.
Yeah. That's quite cool. And we're gonna get into the sort of revolution that bringing AI into the mix is gonna have on music production. But first of all, I just want to like get to some of your work, and I know that you co-created an album with artificial intelligence. So perhaps like some of like the someone like in the audience already know this, but Tristan worked on an album through like his co-creative human plus machine venture that's called Hexagon Machine, and he created an album that's called A Robo Uprising 2021. So I listened to this album multiple times, probably twice or 3 times already, and I think like it's quite interesting because if I remember correctly, like, you trained it on some metal music,
Yes.
but then you did something super smart, which was using a sort of like synth wavy kind of like production there that sort of like hides like the complexity of having a sort of like a real metal band in a sense, but at the same time like it sounds amazing. And guys, like if you haven't like heard that, you should definitely like go check that out, and I'm gonna just like leave the link like down in the description box of this video later on. But one thing like that I'd like to know about this, like what did the creation process look like? So what did you do and what did the machine do?
Yeah. It boils down to the question, if I have an AI tool that composes a piece of music and I just push the button, am I creative or am I not creative? And this is a big matter of discussion, a big question all the time. In that, well, when I just think about this first album that I created, Robot Uprising 2021, it started at Easter, where I had the idea and the inspiration to do that. So I went through a couple of research papers about the transformer, and I always wanted to use a transformer in music composition. And it took me like, I would say 2 weeks to get dataset up and running. So I needed metal files, 7,000 heavy metal MIDI files I found with some annotations that I had to come up with. Taking this and transforming that MIDI information is something that a transformer can understand, and then turning it into a tool where I would click a button and I could repeat certain steps in composition. And this is what took me like 2 weeks. And 3 weeks later, I had the first album on Spotify. So it's just 50 days. And don't get me wrong, like most of the time that I spent was actually composing with the AI and producing and then putting it on Spotify. Deep neural network training, getting it up and running with Hugging Face was like 2 days because I had to learn the software. And the final model that I trained for 4 days on 4 GPUs, and then it was just perfect. I'm still using, as we speak right now, I'm still using this deep neural network in my daily composition work. So it's still amazing. It still surprises me a lot. And well, the detailed question, what I actually did is, first, it starts with a dialogue between me and the AI, which usually takes roughly, like, I would say 5 to 10 minutes in a tool. And if you check my YouTube channel, you can see the tool all the time, where I ask, like I ask the AI, can you please give me a drum beat, for example, starting with a drum beat in death metal, and then it gives me some drums, and I say, okay, that's good. What about laying a guitar on top of that? So it gives me a couple of guitar ideas, and I say less notes, more notes, different style in these things. And once I get like 4 bars up and running, I always hit this random go wild button, which would just continue the composition as the transformer thinks it fits. And then I'll just take 40 bars of music and take the best pieces out of it and rearrange them, turn some into like a chorus, something into verse and bridges, have an intro and an outro. Well, and after 4 hours, one song is finished. That's the whole idea, that I call them like crystallization particles. Like if you have cloud forming, you need some tiny little thing like a grain of sand or of dust in the sky, or else the cloud is not going to manifest. Or like when you have crystals, you also need some particle that the crystal can grow around. And the AI gives me a lot of those particles, these great musical ideas, where that then turn to the next level, and just amazing to work with that.
Yeah, I think like it's a great idea that of sort of enhancing human creativity through the use of artificial intelligence, and what you did is like quite amazing, and the result is also
Thank
like
you.
really, really, really good, like both
Thank you.
sonically and from a technical like perspective. Yeah, I really like that. So
Thank you.
if you want just like to get I would say like a level deeper regarding the technology there. So
Yeah.
what kind of algorithms did you use there?
It's well, GPT-2 language model, the generative pre-trained transformer invented by OpenAI just a few years ago, not so many years, 2019, I think. Amazing piece of software engineering. We are now always talking about that one. I mean, the next level is GPT-3 for text generation. There's also Copilot, which now does the programming for us in almost all established languages, which is just amazing. And well, it's a transformer. GPT-2 is a transformer. And the only thing that this transformer does is takes a piece of text and just predicts the next word. And the magic that had to happen is like me taking music and mapping it to something that looks like text. That's all. And I just take I take a couple of tokens and predict the next token, which is usually the next note. And then generates one more, I put it back, generates the next one, next one, next one. And after a couple of tokens, I have like a bar of music or an entire track or an entire like four track bars. It's the effectiveness is unreasonable, as Andrej Karpathy said, the head of artificial intelligence from Tesla. He has published years ago an article about doing the same exercise with an LSTM, which gave interesting results, but with a transformer, and that's what I saw when I moved from LSTM to a transformer. It can work with more data, and it's way more reliable. It's very, very precise. With LSTM, it was sometimes this occasional note that did not fit. It was like, and when the hair on your neck goes up because one note is not right, and you think about it and you cannot make it really work with that note, so you pitch it up or down. It never happens with the transformer. It's extremely reliable. So all the note events, all the drum events are on point. There's a huge variability and there's no errors in it.
That's cool.
Just
That's
great.
cool. Yeah. And also like the thing that you mentioned here, so the fact of using, or the advantages of using a transformer over a RNN LSTM model. Yeah, also in my experience, these transformers are way more stable and they're capable of dealing with way longer sequences. But here I think like what's quite amazing is that you're basically treating music as a language in the end, right?
Yeah,
Because it's
yeah,
sort of like a series of tokens there, right?
yes, yes.
And with that respect, now let's move from it to like a more like philosophical question. So, do you think like music is a language, and because it could be seen as a form of language, perhaps we see that language models like a
Yeah,
transformer work well with
yeah,
it. So,
yeah.
what's your opinion there?
Well, there are people who tend to believe that mankind was singing before it was talking. We are very musical by nature. I mean, one of the earliest artifacts you find are not drums, but maybe bone flutes. There's so many things in history that kind of connect us with music, and it is my strong belief that music definitely is a human language. It can convey information, emotion. It definitely tells stories, and well, as far as I can tell, humans as a species, there we are obsessed with music. I mean, how many people do you know who are listening to music for quite many hours a day? I mean, I'm listening to music
Of
all the
course.
time. I grew up in a household where there was music all the time, and we add music to movies to increase the atmosphere. Don't get me started on Hans Zimmer, what he's doing with the movies, and there's so many areas in our life that are just plastered with music. So there's definitely a strong connection. It's definitely a language. And when you think about it, well, GPT, like all the transformers, they have been designed in the first place to work with natural language, and they do an amazing job. So if you have a chance to have a look at BERT or GPT-2, GPT-3, and all the other models, it's just marvelous what these things can do with a, well, it's a simple architecture. It's only a little big because it's repeating itself for quite some time. And then, well, to see that those transformers also work for other domains, like the audio domain. I mean, just the time signal, the pure wave file, you can run them through transformer and get results. You can do the same with pictures. I mean, vision transformer is a thing now. This is one architecture to rule them all. And music, symbolic music, well, it's already something that you can read. It's discretized. You have those tokens. And I just have to map them to a text file of those tokens, like node starting, how much time is elapsing, node ends, and then is a bar that ends, a bar that starts. It's something that you can read. It's a little closer to like computer programming because it has a very, very strong syntax in it. But still, you can just look at it and you can see, okay, there's just another representation of music as symbolic events.
Yeah, really, really interesting point here. And I see a very interesting question in the chat by Christus, and it's very related to what like you were mentioning here. So basically, it's like the difference between like symbolic music and raw audio music generation. So can you explain a little bit like the nuance between generating music from symbolic MIDI and from raw audio? So what are the differences there?
And the differences are it's just feasibility. It's both possible. Doing the same exercise with symbolic music is a little easier in like how much it costs. There is a model called Jukebox. It's also a transformer by OpenAI. It has been trained on audio, so lots of music and audio. And using this to generate an audio file for one song takes a couple of hours. So just for one sample. And then you still have to decide, is it good? Is it bad? Oh, I have to change something. And again, another few hours go down the drain because you have to wait for the generation to actually finish. With symbolic music, it is easier in a sense that, well, everything is already discretized. The whole timbre of the instruments is gone. So it's just the note events and you know, well, this is a guitar. And generation is like this, like 4 bars of music per second. No, it's 1 bar, 4 instruments per second. But the timbre is missing. And well, I feel a little trapped because, well, we have way more music in the audio format than we have in the symbolic format.
Yeah.
So we are in a strong bottleneck here, strong bottleneck situation where it's very difficult to find a big data set with like 200,000 or more songs in symbolic music to train on. It's very hard to find.
Yeah, that's so true. And I think also the main difference that you have there is that there's a whole chunk of the generation that you don't address with symbolic music generation, which
Yeah,
is of course like the production part of it and the performance as well.
yeah,
Even if you are within a classically notated
yeah,
musical genre, like for example classical music or arts music, or even some jazz music that can be
yeah,
notated, still there are a lot of nuances in the performance, like for example vibratos, legatos, and things like that that can't really be transferred easily through a
yeah,
notation system like the
yeah,
one that we have, like with Western notation, right?
yeah. Let me just give you an example of articulation, expression. In heavy metal music, when you play the guitar, you have the palm mute, where you just, with the palm of your hand, you mute the strings and then you get some very damp sounds out of it, which is, well, every metal musician uses that. In the dataset that I trained GPT on, there's no indication when it's a palm mute or when it's none. I don't have that. So in the current production, well, now I'm adding more guitar to the music. So I'm working on another album where I have like a synthesizer guitar, which I like, and I add the expression and articulation to that. So I take the raw material from the AI and then say, well, this kind of note, better put it as a palm mute, and it sounds a little
Yeah.
bit more interesting. I add more instruments that are not only piano, but more synthesizers. So I combine timbres of different instruments, and their AI can actually not help me because I don't have an AI that is trained on that. So I'm still recombining the colors of the brushes that I'm using all the time until I have something that I really, really like. But still, using this process saves me, I think, half the time. So when I remember when I was just composing, it can take like 8 hours to come up with an entire song from scratch, and now it goes down to 4 hours because
Cool.
I get high quality material from the AI already.
Yeah. That you can use as a sort of like seed for then
Yeah,
like
yeah.
elaborating on
Oh
top of.
yes, oh yes.
Yeah, absolutely. But I'm also curious about like some of the sort of like constraints that you have, like when you generate music, like with AI. Of course, like there are a lot of limitations still,
Yeah,
even like with the most advanced techniques and
yeah.
transformer networks, right? So, what are like some of the musical limitations that you see when you work with your
hmm
models? So, what are like the models not capable of at this point?
It's multiple things. So one thing is, okay, this is not a property of the model. It's you still need a proper user interface. Another
Right.
thing, another thing that is very, very important is the conditional generation, that you can steer to a high and finely grained degree the generation, like the material that comes out of a neural net. Well, GPT at the end of the day just generates a couple of next nodes, and then there you are. If you do it twice, it's highly likely that you get completely different nodes in it. But there are also a couple of tricks where you could keep a little piece of the generation and then just replace a tiny little piece of that with something new. You can do in painting, for example. If a bar is missing, just fill in the bar. And you can also control it by which instrument to use to generate, and also like what kind of genre to generate. But still, like finding something where you can, with the like turning a knob and you can steer the generation of the material, that's very difficult. But on the other hand side, those approaches, they integrate very well. Well, I never implemented it. I could I could come up with a baseline myself in Logic and then put it into the composing tool, and the composing tool would give me the guitar that fits the thing. So integrating with tools is also another thing. But when we're just talking about the models, the problem of the models is that it's still a challenge for humans to control the generation of the material that comes out.
Yeah, I definitely agree with that. And this is one of the reasons why I think it's very important to have hybrid systems where like part
Yeah,
of the generation, perhaps like at a lower level, is done through some kind of machine learning, advanced deep learning models, but then at the same time have music representation and pass a sort of high level understanding that the models can
yes,
actually have, so
yes,
that you as a human being can interact with the model
yeah,
using a semantic field, in a sense that you can
yeah,
recognize and use, right?
yeah. There's something that I dearly miss, and we see it in other domains. So I talked about that I trained GPT-2, which is
Yeah.
one of the many transformers out of the GPT family. One of the bigger ones is GPT-3, which we heard like 2 years ago, very strong at text generation. And then people found out it's also quite good when it comes to code generation, programming, because it happens that the internet is to a certain degree flooded with source codes. So it also learns source codes. And then I think GitHub, they did the exercise and fine-tuning this on programming. And I program with Codex, it's the neural network, every day, which is amazing because the tool that I'm writing to compose AI music is also implemented by me within artificial intelligence. So it's layers upon layers of human-machine
Yeah, it's
interaction.
quite meta, isn't it?
Yeah, it's like so many. It's connected plans within plans. And what the Copilot with the Codex model does is I could survive my programming days by just writing a comment in natural language, like open a window this size and put a circle in the middle. I can write this down in natural language and it would generate a source code for that. What I'm missing is that I would sit down and say, let's do something that sounds like, I would write it down. Let's do something that sounds like Master of Puppets by Metallica, but tune it down to B and have a little bit more Slayerish feeling to it, while also having a piano on top of that that is kind of inspired by this and that song from Nightwish. Like in text. So far not possible, because text prompted music generation is still a thing of the future. And I think that would really help because I see it every day, how far I can get with just natural language, just write one comment in Copilot, and it generates me an entire class of implementation. And just check if it's okay and maybe fine tune it a little by implementing things. And this is definitely missing. Like not only doing prompts, but maybe saying something or writing something that would already help.
Yeah, I totally get like that thing. And by the way, like I don't know like if you're familiar, but with the Sound of AI community, we are onto a project right now, almost like finishing it. That's called
Great.
Open Source Research Project. And basically what we built was a sound generation synthesizer. So it's sort of like synthesizer that generates like sounds, specifically like guitar sounds, and you have a vocal interface, right? So you can say, hey, give me like a fat, distorted sound, and that like more or less appears.
So great.
Of course, like that is at a lower level. It's a sound level, but something like akin to this, but within the music realm would be like also like very, very cool.
Yeah.
So.
And I have to tell you about that. For me, it's now crystal clear that the whole challenge with composing music with AI is not the neural network part. It's the human-machine interface.
Yeah.
Like how we interact with those neural networks is a thing. Because I spent quite some time on implementing user interfaces for this one deep neural network that I trained last year, and it's getting better and getting better, but still lacking a lot of functionality.
Yeah. I totally agree with that. And also like creating this sort of common language, common grounds and understanding. And then you have the added complexity, which is that it's one thing to have an AI expert talking to a machine. It's another thing to have a musician talking to a machine. It's different languages, right?
Yeah.
Cool. So here I see like a few questions, and some of these I think like are very related to what we were discussing. So there is one from Lancelot who asks, so how do you check for accuracy of transformers? But I would just like extend this question a little bit to say, how do you evaluate the quality of your generation, right?
Yeah. So first of all, Lancelot, great name. My first name is also the name of a knight, so it's very rare to run into another knight of a artist tab around. If you train a model, it's just the softmax, it's accuracy or any categorical cross entropy. That's the number that you get. It's the objective measure of how good your neural network is. And in order to find out how good it is, well, I can tell you after all the time I've spent, you have to compose 3 entire albums using the neural network until you get confidence. I doubted. So I created this neural network last year, and I doubted the quality of what it's generating. I never it was like, okay, no, it has to do some errors. There were moments where I did not dare to click on generate because I feared that it would now do something wrong, but it never did. And what I've seen here is while I was like composing 3 albums, like every time I added more features to the tool around the same neural network, it still like gave me another surprise and another surprise. So, and this is the trouble that we like language generators, we music generators are in, that we do not have like objective measure for different degrees of quality of music that we actually like. Like what is the vibe? What is the emotion behind it? What is the story? It can just tell, well, it has the best accuracy in predicting the next tokens. That's what you see in the numbers. And this is, well, for researchers, always a challenge. You write something, you have a nice neural network, and then you have to do a study with people. You have to let people use the tool, or just create some artifacts with the model, and then you ask people to fill out a questionnaire about one piece of music. And well, because people are people, they lose their attention just after a few songs, and then you have to go to another person and do the same exercise again. It takes a week to find out the quality of those things. So no objective measure here.
Yeah, that's one of the big issues, right? And one of the big differences between AI music, or at least the creative part of AI music, and then
Yes.
AI more in general, right? Where the difference being objective versus like subjective, highly ambiguous evaluation, right? Because there isn't a metric that is going to tell you, hey, this is a great piece of music, but by which standards, you may ask, right? But who's the evaluator there, right? Yeah, but that's super cool.
And that's why I'm not consciously tricking people. I mean, you already said that, especially for the first album, I took heavy metal material, but I used a synthesizer for the actual timbre of the sounds, which kind of pushes it in a completely different domain. I call this like it's cyberpunk metal, so because it's more like technology based, and well, now with the guitars added, I had a little bit more courage, so it's now kind of different. And there is actually on the first album, and it's the only album that has that Easter egg. There's one song that I have composed without the AI, just one. Okay.
And we don't know. We don't get to know which one it is, or did you disclose that information?
I think I actually forgot which one it is.
Interesting.
It doesn't make, because, well, what I've learned is that with a strong and quick curation of musical ideas coming from an AI, it's like me coming up with the same idea in more time. It's still the music that I like.
Right, cool. So let me ask you relay another question from the chat. So Algar is asking a very interesting question that it's going to sort of like tackle the problem of AI human interaction for creative purposes.
Yeah.
So were you ever afraid that the music would be the same if everyone would use the same model for music generation, right?
I am. This one thing where I don't trust this neural network 100% because of the sheer amount of data that I've trained on. I have I'm not sure like how often it's gonna start copying original material. There was one moment in my life when I used the neural network, it generated something that sounded a little bit like The Model by Rammstein. So the old Kraftwerk song, and they reinterpreted it with guitars, and it was kind of like that, but still different. And another moment in time, I got out a strange version of Smells Like Teen Spirit, similar but not the same rhythm, different, same chord progression definitely, drums were different, bass was different, but it sounded a little like Smells Like Teen Spirit. So you can discuss like is this a copy or is it not? So far, everything that I have uploaded to YouTube passed the copyright check without incidents.
Right, but what if you had two people using, for example, your model? So do you think there's still enough creative room for people to sound different or to compose differently?
Yes. There's one knob that I do not turn that often. It's the temperature, which translates to the degree of randomness. So it predicts something like a distribution. You can flatten the distribution, allowing nodes that would not be the next node to become the next node. And then the higher you go, the more randomness you will add to the generated part. But definitely, yeah, if you said two people next to each other, there's a certain chance that they would compose similar things, but maybe it would take months clicking until this actually happens.
Right. That's cool. Okay, so here we have another question by Varun. So what's your view of the Google's Magenta's T5X transformer? When we used it for some of our WAV files dataset, we could not get accurate transcription to MIDI. Do you suggest using GPT instead?
Well, the thing is that GPT in most of the use cases is kind of trapped in one domain. So it's either symbolic music or audio files or pictures or and so on and so forth. Music transcription, I'm not aware of the work that they've done there. I only know their onsets and frames model. That is quite interesting. But I can just motivate everyone who's working on automatic music transcription to, well, kind of double your efforts, because if you're successful, you're gonna change the game, because you're gonna help us, and not only me, but quite a lot of people out of the bottleneck situation. So music transcription, especially when you have music that is beyond just piano work, with high quality, high accuracy, desperately needed. So good luck and keep me updated. I need actually that.
Yeah,
and
and I think
just imagine that you take the catalog of some artist that you like off Spotify. Well, I'm not suggesting to do that, but maybe you have some source material, and you just throw it into automatic music transcription. You get a data set immediately, and you train it, and you get something in that style, and it's just amazing.
Yeah, I think like this is a really good point, and it just shows the sort of relationship that you have in AI music between the more analytical side and the more creative generative side.
Yes.
The two feed into each other quite a lot.
It's like a feedback loop is intertwined.
Yeah, absolutely.
Definitely necessary, because I mean, there's even the thing, and Magenta has MIDI DSP, which is exactly that you have on one side you have original data in audio form, and then you go to something that is symbolic, and then you resynthesize it with deep neural networks into audio again, and you can go in multiple directions there. It's very, very powerful. I mean, audio analysis is one thing, audio generation is another thing, and if you piece it together, you just put symbolic music generation in the middle, hopefully controllable, and then you are full circle.
Yeah.
And we are very close to that.
Yeah. So we have an interesting comment here by Nima, getting back like to our idea of evaluating like the generation like that we do like with a model, right? Can one use the reconstruction error of a VAE for checking the quality of the composed song? So I see like a few problems there already. So it's basically the idea is that like
Can you give me the name again?
So the name Nima. So Nima.
I guess it's a dear friend of mine who is like always a candidate for asking those great questions. So shout out to you if it's you. Well, and the question was using the reconstruction loss of a variational autoencoder in order to assess the quality of the generated material.
Yeah.
Ooh, that's something that I have to think about, the reconstruction loss. I mean, there is this variational autoencoder called Music VAE by Magenta, which is working with, it works with symbolic music, and they take a certain loss into account, but still after that they do a lot of studies. And they do studies with, this might be a thing. They do studies with a labeled data set. And then they try to find attribute vectors and clusters in the latent space, which you could use to evaluate things. Like a couple of things should cluster in the latent space of those variational autoencoders. You can see something like that, but this is not a reconstruction loss. I have no idea. I have to think about it. It's a great question.
Yeah, I think like it could be used potentially to understand how far off from like a certain like trap or something like that. You actually are, but at the same time, I don't know like if that is something powerful enough like to understand the quality of the music. You can, please go ahead.
Well, if you train a variation autoencoder on a small data set, the chance is high that you can find those outliers or those anomalies by just looking at the reconstructions. But well, the problem with the variation autoencoder is the encoder tries to make sure that you're always in a good position in the latent space, right?
Of course.
So that the decoder generates something that makes sense. And I've seen this with pictures, that it actually reconstructed images that were definitely not in the distribution of the data set that are trained on, approximating that, and it still gave a low reconstruction loss. So it fooled the system. I was like, okay, wrong. It didn't work.
Cool.
But it might work. Interesting, yeah.
Cool. Okay, so now let's just go like up one level. So we've sort of like navigated all the way down to the bottom of the sea in a sense, right? So let's go back up. So what will be for you the long-term impact of AI on music creation for musicians, for the industry?
It's under the umbrella of augmented human productivity and creativity, both of those things. So it's going to allow people to produce and compose music easier. So an example would be you are someone who would love to compose some music, but you don't know it yet. So you did not go through any education, don't know about music. You can just start Logic and try like clicking around. And this would give you a couple of ideas. Well, and don't get me wrong. A lot of people who are not composers and who are not performers are great in intuitive music understanding. So you know what is a good musical progression because you have been exposed to a lot of music. So people can judge if you give them some material, maybe even created by an AI, if it's good or bad, and then they can curate this and turn this into entire songs without understanding the basic triads and how you turn them into chord progression. So that's one thing. So people who are not yet experienced can go into the music composition domain easier, and they're also going to learn that because you're exposing them to patterns, and you're going to see them explicitly in a symbolic notation that you have to work with. But also on the other hand side, and this is like also creativity and productivity, if you are like a skilled person working in that domain, it is, again, as I'm always saying, a lot of ideas that you can just draw from. And sometimes it's easier to draw from a pool of ideas instead of coming up with the ideas yourself. Also, it can give you some ideas that are not perfect and you kind of correct them, add something to it and turn it into something better. It's also something that I do. And also it's going to be faster. I mean, if you have a piece of music and the drums are missing, you just start GPT-2 and it generates the drums for you and say, okay, this is not good. This one, do it again. And then there you are. And you saved like hours of clicking or recording and all these things. So that's it in a nutshell. So people, it opens the door to more people. They just have to curate samples from AI in order to create songs. And also people that are using this on an everyday basis are going to get tools that are going to make their life easier.
That's cool. So one question that's connected to that one, to the previous one, is how do you see the role of the composer or the artist, music artist, changing?
Yeah.
Right? What are the skill set that the new composer should acquire?
New composers. Today is you have to be capable of spinning up Magenta, Jupyter notebooks on Collaboratory, and then kind of find out how to integrate this with Logic and so on and so forth. It's a rather high bar. It's still very difficult to connect those we can say pure musicians who don't have a computer science background or PhD in computer science with those things. Example would be, well, music VAE, in order to be creative, you have to navigate a latent space. I mean, what does this mean? Navigating a latent space in order to find samples that you can, I mean, it's I mean, it's an interesting idea when I think about it, but it's hard to pack into an easily understandable user interface. But there are people working on that, and I've seen convincing results, so it's getting there. So what I'm just waiting for, and I'm also like actively working in that direction, you have to take those approaches and put them into nice tools that you can run in Cubase, in Logic, in Ableton Live, and so on and so forth. It's just some tool that you open, you do a click, and you get a perfect guitar solo.
Right. So you think that there's going to be some sort of simplification of all of these tools and productization, right? So way less experimental and more product.
And we are definitely getting there. I mean, when we talked about me training GPT-2 on heavy metal, I cannot stress this enough that the actual part of training the neural network was almost neglectable. It is definitely, it lived in the shadow of me having to get the data set, curate the data set, encode the data set in something that a neural network can train. For me, training GPT-2, it took 2 days while I was babysitting my niece on Easter to get this up and running, because I had to go through the manual of Hugging Face. I had to learn the implementation of Hugging Face for GPT-2. And once this was up and running, everything else was just a walk in the park or on the beach. But this is fairly easy, and this is no comparison to the first experiments that I did. Those were horrible. I mean, setting up the LSTM and training and these things, and here was just data, transform it, and then plug it into the whole thing. And I worked with a paper called MMM, for multi-track music composition, and it's one of the most amazing papers that I've ever seen in music generation, because it talks almost exclusively about encoding the data, and there's a tiny little paragraph about, well, we just take GPT-2 with 6 layers, 8 attention heads, embedding size is 512, sequence length 2048, trained with Hugging Face. There you go. That's all. No strong elaboration on a neural network architecture, just here are the parameters, go, works. It's amazing, and things are getting easier. That's the point that I would like to get across. I mean, if like 2 years ago was still difficult, or more difficult to get everything up and running, now it's easier. And if you extrapolate into the future, it's getting easier as we speak.
Yeah, I would agree with that. But at the same time, I think that the figure of the composer, of the artist, is moving towards more technical, I would say, right? So it's a little bit like the difference that you had for music producers or music composers, like before the advent of digital audio workstations, right? They worked just like in studio with a lot of hardware, but then they had to learn the skills, like software skills, right? Like, for example, using Cubase or Pro Tools. But now I think that AI opens up a big opportunity for them. So some of that will be like easy for them to use. Other stuff probably, if they want to be on the cutting edge, they will have to hack around. So in a sense, I envision the work of the composer to be more in synergy with that of a hacker, in a sense, right? Playing around with models, knowing just enough Python for hooking together like data sets and models and playing with that.
I mean, that's the story that I told you here, that it started with a data set.
Right.
And then at the end, it's some music and logic, and it took a while to arrive there, but already things are in place. So it took like 50 days for me to do everything, because I'm trained in doing the neural network part. I know that the things are getting easier. And recently there was a release of MIDI Talk, which is a Python package that helps you encoding MIDI files into something that a transformer could understand. So this is already something that you can check off your list. I mean, the whole mapping to something that a neural network can understand. Hugging Face, I cannot stress this enough. I mean, Hugging Face, the logo itself, is just amazing piece of software and a great platform and great infrastructure. I mean, this just, again, is so easy to work with that, and you get excellent results with that. So it's not a commercial. I really love those guys. So it's amazing what they are doing. And if this is just a start, how would this look like 5 years down the road? And we're getting more compute, which is also a thing, faster compute. And they're also optimizing to a certain degree the models, so they're training faster. So it might be a case that soon we're going to have more artists composers who for quite some time gather a corpus, a data set. So we love data sets, and throw it into some neural network, maybe even a pre-trained neural network that is fine-tuned, which then lives in a tool, and then they use it for composing, hopefully without too many Jupyter notebooks, without too much programming. But I think this is coming.
Yeah, I couldn't agree more. Yeah, with those statements, right? So now I just had something that I wanted to ask you, and probably we are like sort of bridging into philosophy here, right? So because what I want to ask is like, first of all, like creativity has been traditionally seen as a human trait, I would say, right? Something that's bound, that's connected to human beings, right?
Yeah.
I would say something has changed since the advent of AI in the creative space, right?
Yes.
So I'm really, really curious to hear like your thoughts about this. So first of all, how would you define creativity, and how's the intervention of AI in the creative space changing your and our understanding of creativity as a species?
Well, creativity, it's the activity of creating something. And this is not that much. I mean, if you come up with a slight variation of a recipe in the kitchen, you have been creative. So it's no doubt about that. And if you take a look at creativity of mankind, I mean, we are standing on the shoulders of giants. There's so many things that happened. I mean, just get me started on the music composed in the Renaissance. What has happened there actually? How the music evolved in just a few centuries to that. I mean, we're still beating the drums, and suddenly you have the Bach music performed in churches. I mean, just great what happened there. But also, quite a lot of human creativity is a thing called inspired plagiarism. So you listen to something and you change it to a degree that people tend to believe that it's something new. And there are people who say that's roughly like 90% of all the creative exercises that we do. So we're kind of repeating ourselves with tiny little variations, still adding to the pool of artifacts. Sometimes you see a certain like spark of genuine creativity when something new happens. When you see that, you have a guitar, but you cannot hear the guitar because there are too many people in a large room. What about using an amplifier on the guitar, just connected to a speaker? And then you realize there's this knob you turn up, and then you have a distorted guitar. Suddenly, rock music, right? That these things happen that are not really, really predictable. It might be the case that AI is also capable of doing that. But I think there's always going to be a strong difference between AI creativity and human creativity, because it's just two completely different approaches how to do these things. So far, I mean, we're working on that. So far, the AI is extremely limited. So my AI cannot draw any inspiration from the weather outside for the next song. It cannot do that. It's just about the notes. It's just living in note space. Me, on the other hand, if I have a bad stomach, I might compose something completely different, like all the composers did, right? And looking at a picture and then getting a melody associated with that. So multimodality is something that we still don't have. Also, understanding the big picture. There's currently something that the neural networks struggle with, like the whole storyline. So if I let my AI loose, it's gonna create quite a lot of music, quite a lot of bars of music. It's meandering, but it's not really telling a story. It's not so many repetitions in that. If I have something that sounds like a chorus, it's not gonna be repeated after the verse. Not happening. This is what I actually add. I take those pieces and turn them into a story. Also, GPT is a writing tool. It works. It can generate, I think, 1 or 2 pages, consistent text, but then it's going to lose the context because it doesn't have access at what it has written before and kind of forgets that. And then it's also meandering. So you kind of push it in a certain direction and it comes back on track. And maybe this is gonna go away once we have even bigger models. But still, I think that computer creativity, human creativity are gonna be two different things, but they look lovely if you integrate them.
Yeah, I think like this is like a really really interesting like take on the whole thing. And regarding like your two differentiation there of types of creativity, Margaret Bowden, like philosopher and cognitive scientist, would say that like the one that you described as researching and creating variations of something that's already there, she would define exploratory creativity, whereas the other one, the more drastic, that sort of obliterates the I would say like the actual conceptual space, she would call transformational creativity. And I think like you really really like got like these two like really nicely. And I think honestly that right now AI is only capable of exploratory creativity. I don't know if AI is going to ever be able to get to transformational creativity, but
there's a certain tendency. I mean, it shows things. I mean, Andrej Karpathy wrote his article about the unreasonable effectiveness of recurrent neural networks, I think, in 2015. And it could generate something that resembled Shakespeare, but there was no connection inside what it has written. Sometimes even it made up words, but it did not really tell a story. And then we saw the next step where we went from character prediction to word prediction with word embeddings. And then you can see, okay, depending on the context, now it's telling a little bit more of a story, but it's losing itself like quickly. And now we see with just a bigger neural network architecture and way more data that these neural networks, they can keep the context for quite a lot of predictions and tell a longer coherent story, but they lose it after quite some time. And that's the thing. It's just taking a look at the past and then predicting the next thing. It's not jumping like we do. We are thinking, and then we think about the chorus as like a high level thing, but it also has its low level expansion, like the notes that are inside it, the text that is inside it, and we kind of like mix those layers, those levels all the time when you think about these things. The access things here and combine it with that. And still, I have not seen a neural network that is capable of doing this like in a really, really strong way. I think it's kind of coming. Yeah, with bigger neural networks, with bigger transformers, it might do something, but at the end of the day, there's still a brute force approach.
Yeah, this is why I think it's extremely important to have knowledge representation done the right way. Having an intelligent manner of representing musical knowledge at different levels. And this is why I think it's just so important for automatic AI music generation to have the combination of rule-based systems, knowledge-based, as well as like machine learning.
Yeah, and that's the most important point. If you think about the human brain, you can teach the human brain to work in a rule-based mode. I mean, rationality as an example. Many things that we do on our everyday lives, they are not rational. They are more like instinctive, automatic. But still, you can use the brain and you can teach someone logic to do the planning, for example, be consistent, be rational with what you think. I mean, the scientific method is a thing that's very, very important. Like you have, I mean, we've been discussing the scientific method for now 2 years without end, and we're still learning about that. But on one hand side, you have the musical intuition of a lot of people just being exposed, but they cannot put this into a rule system and write it down. If you teach them, they can do that. And then they may be on a different level, maybe heightened expressibility, better understanding of these things, and continue from there. Maybe we would have neural networks. Maybe it can be a big language model with a trillion parameters or something trained on gazillion megabytes of data that would express what it has learned just from the data and could write down the rule behind that. And well, there are transformers who can do mathematical reasoning now. They can do mathematical proofs, but just being exposed to a lot of data. And this could also be a little scary, but I think at the end of the day, those AIs are just going to make our life easier.
Yeah. Totally agree with that. And the path forward probably will be this combination of like bottom up with the top down. So with this like the coming back to the good old fashioned AI in a sense, right? Which having like a revamp of that.
Right.
Okay. Yeah, so Tristan, like it has been like really like amazing just like chatting with you, and I think like we could just
Agreed. Yeah.
continue
Yeah.
right for hours and hours. But one couple of last questions here. So
Sure.
one comes from Nikas from the chat. I think it's not really like connected with music generation, but I'm curious to hear your take if you're into like music source separation. So Nikas asks, is it worth to try and experiment with perceptually relevant time frequency transforms, like for example, constant Q transform in the context of music source separations?
Whew. Well, definitely not my field. Definitely not my field. I think the good old FFT might not be enough, and I can just ask people to have a look at the DDSP by Magenta, which is kind of trying to learn its own synthesis. And by learning its own synthesis, it can come up with very, very great, like latent space representations of the musical material just based on, I think, the mouse spectrogram. So I'm still waiting for someone to implement DDSP for source separation with multiple synthesizers and can just take everything apart. But, well, definitely not my field.
I would agree with you. Like, I mean, like, of itself, and
Yeah.
definitely like not solved. But I mean, like
we are getting there. Don't get me wrong. We are getting there. I mean, just quickly talk about DDSP. What DDSP does is it's a neural network where you put in a piece of sound, well, piece of music, and on its way, it does F0 detection, so the base frequency, and it also finds the parameters for a subtractive and additive synthesizer in order to recreate the same sound. And the great part is D, the first D is differentiable. So the synthesizer is something that you can actually train. You can push a gradient through it. That's why it's so effective. So in that said, people have found out that they could replace, there are people working on having more synthesis there, more differentiable synthesizers that you can use. And also, there has been an approach which was quite successful, that instead of having a differentiable synthesizer there, you can plug in sound plugins that we know from music production, where you could not push a gradient through, but they had a trick to jump over the thing. So you could find a neural network that would predict the parameters of your compressor and your limiter and your reverberation in order, for example, to do pre-mastering and mastering. So going through that. So I think around the corner might be a matter of like computing power. There would be a deep neural network that could control the entire logic. Like Logic Pro, turning those knobs, generating something, maybe in combination with some deep reinforcement learning. Nobody knows. Still, it's a long way, and that's the thing that I like the most. It's not solved. AI music or computer music has been around for quite some times. I mean, I have an LP here from the end of the 50s, like the first Markov chain, this string quartet generated by a very, very big computer. It's hard to listen to. Oh, it's not so good to the ears, but it gives you a strong feeling of being pride because standing on the shoulder of giants, and has been evolving and is still evolving. So this is definitely not a dead end. It's just going to continue.
Yeah. Yeah, this is a great note to finish our interview here. One final thing that I want to ask you is, what do you suggest the Sound of AI audience to do to get into AI music generation? What courses, what things to learn?
Well, when people ask me like how can I get started, then I usually give them a homework, and the homework would be train an LSTM on the Johann Sebastian Bach chorales. And it's getting easier every day. It's getting easier. So there's a publication. I think it's a thesis, maybe it's a master's thesis, called Bachbot, or Johann Sebastian Bachbot, which goes into the whole implementation part. And this would be like the first thing that you should solve, like the first like big milestone. On the other hand side, well, it's a nice way to start with deep learning. I mean, deep learning is currently a very, very nice thing to use for music composition. So you have to learn what is deep learning. Start with MNIST. Then you have to learn what is an LSTM. Maybe you do IMDb classification. Is a piece of is a movie review good or bad, like these standard things. And then you go into next token prediction. And this can be text. I mean, just start with text, and then the only exercise would be take your music and map it to text and do the same exercise. So when I am teaching NLP, I always make sure that I squeeze that in. So when next week I'm going to be in Berlin in data science retreat, so I'm going to teach NLP. And so people who are listening, I'm going to also teach the language generation. I always do. I ask people, get your own corpus, get, for example, the entire Harry Potter, put it into the LSTM of a transformer, and then generate something with that. And that's actually what you should do. And and now, if you like to do that, there is this great Hugging Face course, recently updated. And in chapter 7, I think, they have a subsection about language generation with the transformer, actually for programming. But I tell you, if you can do programming, you can do writing and music. If you can do writing, you can do programming and music, and so on and so forth. It's just exchangeable. You just have to change the data set.
Yeah, great advice, Tristan. Thank you so much. Yeah,
You're
it's
welcome.
been great to interview and having you here like as the first guest.
Yeah,
The Sound of AI
I
conversations.
feel honored. I feel honored. It was really, really great talking to you again.
That's cool. So yeah, thank you to everyone who showed up here as well. And I'm sorry that I had a slight technical issue with my camera, but this is the first time doing like live streaming. So, I mean, it can happen. So next time, hopefully we're not going to have that issue, but thank you everyone for showing up, and especially Tristan, once again. We'll see you and we'll talk in the future.
Yeah.
Good luck with all of your projects.
Thank you very much. Thanks for having me. I feel honored, and I would love to come back anytime.
That's great. Cheers for now, guys. Bye-bye.
Bye-bye.